Okay, so the last time we looked at the OSI model, this time we're going to look at the DoD model. It's a little bit different, but basically it accomplishes the same thing. So let's go ahead and look at the desktop. Okay, DoD model. Basically, it's an application layer. That is the highest layer of the DoD model. That's where network-aware applications interact with transmitted data, just like layer 7 was the application layer of OSI, and layer 4, the application layer, is the highest layer of the DoD model. Don't forget, you need to complete these interactive activities that are embedded in the lesson. Transport layer, that is the DoD model layer where end-to-end payload delivery from source to destination occurs. Port address, basically, that is the port number. It's a 16-bit unsigned number that uniquely identifies a network application or service on the host. If you're, when you are typing in IP addresses or you're setting up a firewall and it asks you for port numbers, this is what it's talking about. Basically, it's the number for, now you can think of it, it's an abstraction to think of it as a port or a hole in the firewall, but it's really just a number that labels the packets, or that labels the, basically it labels the packets and lets the application or the receiver or host know that it's getting the correct information from the correct, that information is going to the correct service. So if you've got a packet going to an IP address of 192.168.1.1, basically there can be a lot of different servers or a lot of different applications running at that IP address. And so the port number specifically tells which application needs to handle that packet. So if it's port 80 or port 8080, then we know that the web server that may be running at that IP address needs to handle it. If it's port 21, then the FTP server running there needs to handle it. So the port address is basically an assistant to the IP address. Not only tells it the location that it gets from the IP address, but it also tells it what application that it needs to handle that kind of data. TCP header is a 10-field, 20-bit header containing connection and payload delivery details. And basically, these are the fields here. And this is the description of each field, and this is how many bits. Remember, a bit is a single binary digit, either a 1 or 0. That means this one has 16 characters, as does this. This one has 32, as does this. This one has 4. This one doesn't have any right now. It's reserved for future use. This one has 6 characters, 16, 16, and this one can be anywhere between 0 and 32. So depending on what kind of network it is, this last TCP optional data may or may not have any data in it. The UDP header is a pardon me, let me try that again. A UDP header is a much smaller header. It only contains 4 fields instead of 16. It only takes up 8 bytes. Basically, a byte is 8 bits, so 8 times 8 is 64. So there can be a total of 64 bits in this header. Source port, that's the 16-bit source number. Remember, we learned that a port was a 16-bit unsigned number. Well, the source port is where that data is going. That's the application that it needs to use to open that data. Source port's where it came from. The destination port is where it's going, and that tells us what application needs to handle the data. The length can be up to 16 bits. And the reason that we know that is because 16 times 4 is 64, and that's how many bits are in 8 bytes. And then finally, the checksum is a 16-bit number that allows the receiver or the sender, basically the sender sends verification of header and payload integrity, and the receiver can read it. And that verifies that the packet is a legitimate packet. Once again, we have another application. Internet layer. This is in the DoD model, it's where hop-to-hop data delivery. A hop is traveling between 2 nodes, can be between 2 servers or between a client and a server, or between Anywhere there's a node, anything that is connected to the network and is network aware is a node. And any traveling between two nodes is considered to be a hop. IP header is a header containing connection and payload delivery details. So the IP address, for example, would be in the IP header. IPv4, those are what you're thinking of as an IP address. Basically, IPv4 is the original IP protocol. Unfortunately, it's finite in its number of available addresses. And unfortunately, we're running out of numbers. So they had to develop IP version 6. They never did develop version 5 fully. So nobody ever talks about it. The 6th version of IP provides internetworking capabilities for packet switch networks, but basically it has a lot more, the address is a lot bigger, has a lot more bits in the address. And so there's more information you can have there. And that means you can have more clients, more servers on a network. The header for an IPv4 is 14 fields. It can be up to 60 bytes, which means 60 times 8, 480 bits. It contains connection and payload delivery for an IPv4 packet. An IPv4 address is a 32-bit numeric address, 192.168.1.1, for example. That is 4 8-bit or 8-character octets. We call them octets because they are 8-bit, and they can be anywhere between 0 and 255. So you can have 4 groups, usually separated by periods. The field looks like this. Version, that's a 4-bit number. It's the IP version, usually IPv4 in this case. Header, internet header length, that's going to be a 4-bit number as well. So 4 characters. It can be up to 1111 in length. Differentiated service codes, these are just different parts of the header and how many bits they take up. So if you add that up, and then when the varies one comes up, that's the difference between whatever number this adds up to and the total number of bits available to the header. IPv6 header is 8 bits, a 40-byte header containing connection and payload, just like the IPv4 header. The IPv6 address, however, is a 128-bit number, usually in hexadecimal, whereas the v4 is only 32 bits. And that's the difference. That's the main difference between v4 and v6 is that you only have 32 bits to work with here, which limits the number of nodes that you can have on your network. It limits the number of clients and servers you can have. And frankly, we've run out. Just that's what it is. There are just not enough numbers to account for all the computers on the internet. So we switched over or are switching over to IPv6. There's still a lot of v4 networks out there. Fortunately, computers don't really care. They can intertranslate. So an IPv6 address is much larger. In fact, it's 4 times larger than a v4 address. And this is what the header looks like. It only has 8 fields. Those are the different bits or different sections of the header, and that's how many bits of information they can contain. And that information allows the sender and receiver to communicate. Once again, you have an embedded assignment here. Network access layer. That's where the data transfer between 2 devices on the same network occurs. The IEEE is a professional organization that advances technology through technical standards. And basically, they are the ones that set these standards. For Ethernet, for example, it's a series of LAN protocols, IEEE 802.3. These are protocols, devices, and connection methods that are certified by the IEEE. An Ethernet frame is 6 fields and 64 bytes, which means 512 bits of information in 6 frames, and it's a header and trailer. Basically, it contains MAC addresses, among other things, transmission parameters. That's what goes in that frame. Media access control address is the same thing in the DoD model as it is in the OSI model. Basically, it's a 48-bit identifier that's hard-coded into a network card or some other network-aware device like a network switch. Every network-aware device has a MAC address. Network card, basically, if you're familiar with the card in the back of your computer that your network cable plugs into, that's a NIC, or a network interface card. This is what an Ethernet frame looks like. And then you have a participation activity here, as well as a challenge activity. And that covers the IP, the DoD TCP/IP abstraction model. Okay, guys, once again, if you have any questions, contact me via the Canvas inbox or let me know in class, and I'll do my best to answer those questions. Have a good day.